Namaste everyone.
Namaste.
Namaste, sir.
Namaste, sir.
Namaste everyone. Okay. So today we are going to start with the revision of all the chapters we have done. Okay. We'll start with the first chapter, real numbers. First of all, we'll see the basic concepts which I've learned in detail during the lectures we have had before. Okay. We'll just go through the basic concepts. Then I'll give you some questions. We'll practice some questions. And then I'll give you some set of questions for you to practice at home as well. And then we'll discuss those questions in the next class. Okay. So what we are going to do, I'll just write here so that, the same we are going to follow for all the chapters. Okay. Number one, I already typed in the message right in the WhatsApp. Let me copy that. Okay. So we'll revise the concepts of each chapter and solve some previous year questions. One more thing, please don't depend solely on this class for revision. You please revise and come, because we have seen each of the concept in detail. Okay. Every concept we have learned in detail during the class. So here we are just going to revise. Okay. I cannot teach everything in detail. Okay. So if you feel that you are lacking in the basic concepts, please refer to the recordings. The recordings are already available in the Google Classroom. Okay. So please refer to that. Okay. So we'll just revise the concepts, okay, and solve some PYQs for each chapter. Then I'll give some set of questions from the board examination. It can be previous year, it can be sample papers, it can be compartment papers. So I'll give you questions from that for you to practice. Okay. You have to practice those questions and you have to submit in the Google Classroom. Okay. And then we will discuss those questions in the next class. Next class in the sense, for example, if I give it today, next class for maths is on Friday, right? We'll discuss on Friday. Okay. So it will be like that. Okay. So you cannot take your own time now. Okay. You cannot take your own time. You have to complete, before the next class. Okay. Then for each chapter, we'll conduct MCQ test. The MCQ test for each chapter will consist of, average 25 questions. Each chapter, 25 questions I have prepared like that. Okay. So you please, if you revise properly, if you do the questions, then only it will be effective. This revision will be effective. Now, once the revision is completed, you'll be also writing full syllabus test. Okay. So we'll be conducting 10 full syllabus test, or we can call it as mock test, 10 mock test. Okay. Okay. So let's start. And same way we'll follow for science also. Whatever we are doing for math, same way we'll follow. Okay. Okay. So I'm going to share my screen. We'll just use the class notes. Okay. To revise quickly. Perfect. So in the chapter real numbers, first of all, we had seen what is natural numbers. Natural numbers are nothing but counting numbers like 1, 2, 3, 4 up to infinity. Yes. Natural numbers, we use capital letter N to denote. Okay. In 11th standard, when you go, right, you will study a chapter called sets. In that, instead of writing natural numbers, they will use letters. So wherever capital N is there, it means it is a set of natural numbers. Whole numbers are numbers which actually include 0 and the natural numbers. Okay, so 0 and the natural numbers, that is actually whole numbers. We use capital W for that. Okay. Next, we saw integers. Integers are the set of numbers which include 0, positive numbers like 1, 2, 3, 4 up to infinity, and negative numbers like -1, -2, -3, and so on up to -infinity. Okay. So here we have both positive, 0 we have first, positive and negative. Okay. Now, if you look at positive integers are 1, 2, 3, 4 up to infinity, right? So they are also called as positive integers, are also referred to as natural numbers. Sometimes in the question they will use positive integers. So positive integer means they are natural numbers. 0 is neither positive nor negative, and these are negative integers. Okay, perfect. Then we learned what is a factor. Factors are nothing but exact divisor. Exact divisor means remainder is 0. That is the meaning of exact divisor. So factors are nothing but exact divisors of any given number. For example, if I take 6, okay, if I take 6, 1 can divide 6 because 1 6 are 6, remainder is 0. 2 can divide 6, 2 3s are 6, remainder is 0. 3 can also divide 6, yes, 3 2s are 6. 4 cannot divide because remainder is coming 2. 4 cannot divide exactly. 5 cannot divide exactly because remainder is 1. 6 can divide. So for the number 6, which are the numbers which divide 6? 1 can divide, 2 can divide, 3 can divide, 6 can divide. That is why 1, 2, 3 and 6 are factors of 6. Okay, we have learned all this in detail. Okay, anyway, I'm just telling you in brief that factors are what? The exact divisors of any given number. Okay, so same way, if you take 1, 1 is a factor. 2, 1 and 2 are the factors. Why 1 and 2? Because 1 can divide, 2 can divide. Okay. If you take 3, 1 and 3 are the factors. 4, 1, 2 and 4 are factors. 5, 1 and 5 are factors. 6, 1, 2, 3 and 6 are factors. 7, 1 and 7 are factors. Okay. If you observe carefully, 1 and the number itself, 1 and the number itself, see 1 and the number itself, 7. 1 and the number itself, 3. 1 and the number itself, 4. 1 and the number itself is always and always a factor of any given number. Please remember this. 1 and the number itself is always a factor of any given number. Next, we have something called as a prime number. What is a prime number? A number having exactly 2 factors. Please remember, exactly 2. Not more than 2. Exactly 2. Not less than 2. Exactly 2. Please, exact means only 2. Okay, exactly 2 factors. For example, if you take 2, 2 is having 1 and 2 as a factor, 3 is having 1 and 3 as a factor, 5 is having 1 and 5 as a factor, 7 is having 1 and 7 as a factor, right? So all these are prime numbers, and we can keep writing. I have actually stopped till 7, but we can keep writing, right? So a number having exactly 2 factors, they are called as prime numbers. Next, we have composite numbers. Composite numbers are numbers having more than 2 factors. So if you look here, whatever numbers I have written, if you go in order, 1, 2, if you keep going from 1, 4 is the number which is having 3 factors, 1, 2 and 4. That is why 4 is a composite number. So composite number have more than 2 factors. What about 1? See, 1 is having only 1 factor, that is 1. 1 is having only 1 factor, that is 1. For a number to be prime, it should have exactly 2. So it is not having 2 factors, so it is not, 1 is not prime. For a number to be composite, it should have more than 2, but 1 is having only 1 factor. That is why 1 is neither prime nor composite. We just say 1 is neither prime nor composite. We don't have a special name for that. We just say that 1 is neither prime nor composite. Okay. Now, if you observe carefully, if you go starting from 1, if you keep going, 2 is the smallest prime number. Very important. 2 is the smallest prime number. And 4 is the smallest composite number. 4 is the smallest composite number. Now, please read the question very carefully. There was a question in one of the board exam where they asked, okay, the LCM of the smallest prime number and the smallest 2-digit composite number. So students, I mean, generally they will just read smallest. They will not see 2-digit. See, smallest prime number is 2, but smallest 2-digit composite number is not 4. 2-digit. What is digit? See, so for example, if I write 487, 7, 8 and 4, these are called digits of a number. Digits. These are digits. So for example, if I write 27, 7 and 2, they are digits. DI, digits. They are digits of the number. Clear? So read the question very carefully. So can you tell me in the chat box which is the smallest 2-digit composite number? All of you in the chat box, which is the smallest 2-digit composite number? Yes, Amrita. Yes, Yogesh. Yes, Somil. Yeah. Ritiya, I mean, now only I have actually told something. You're not listening. What is my question? Unmute yourself. Ritiya, unmute yourself.
Smallest composite number.
Smallest composite number is the question. Okay. Yogesh, what is the question?
Smallest 2-digit composite number.
Ritiya, you have to focus. Okay. All of you have to focus. Okay. You have come here to learn for 1.5 hours. Next 1.5 hours, you have to devote your entire energy into this. Okay. And actually, it's not only, I mean, see, Ritiya, actually, you have answered 4, right? And actually, I have told that thing also that you have to read the question very carefully. Smallest composite number is 4, but 2-digit is different. 2-digit. It is 1, 0. That is 10. 10 is the smallest 2-digit composite number. Is that clear? Yes or no? Yes. Everyone, please pay attention. Okay. And we have discussed a question in class also. During regular classes, we have discussed. Okay. Okay. Next, let's move forward. Multiples. We have understood what is a factor. Somil, what is a factor?
So factor is any number which is divisible by the given number. Any number which divides the given number.
Wait. Why? What you told in the first place? Any number which is divisible, you told, right?
Yes, sir.
Any number which is divisible
By a given number.
by a given number. Okay. Any number which is divisible by a given number. Now, there is a difference between divisible and divides. Both are not same. Divisible and divides. Okay. See, you're saying any number which is divisible. Okay. See, for example, wait, I will tell you. What example should I give you to explain this? 1 minute. See, this, first of all, this statement is not correct. Whatever you said, no, it is divides. Okay, any number which divides, like, don't say divisible. Okay, any number which divides. Okay, see, this number is divisible. This number is dividing. These numbers are not, these are not divisible. See, 1 is not divisible by 2. You understand? 1 is, see, 1 you cannot divide by 4, but 4 you can divide by 1. So that way you should not say. I mean, whatever you have said is not correct. You understand? So whatever you're saying, you have to be very clear also. 1 is not divisible by 4. 2 is not divisible by 4. 2 is not divisible. Okay, 2 is not divisible. You are saying any number which is divisible. Okay, it is not divisible. It divides. Okay, you know the concept, but still you have to say in a proper way so that in the exam, when they ask a question, you should not be confused. Okay, clear?
Yes.
Yes. So any number which divides. Okay, so that is why I told factors are what? Exact divisors. They are divisors. Okay, exact divisors. Okay. But see, if you look carefully, factors are not divisible by this number. See, look here. See, for 2, factors are 1 and 2. But factors are not divisible by this one. 2 cannot divide, 2 can divide 2, but 2 cannot divide 1, right? Yes or no? So be clear as to what you say. Okay, very important. Perfect. So next, we learn multiples. Multiples means whatever you multiply a number to get the next number, that is a multiple. For example, for 2, multiples can be 2 into 1, 2 into 2, 2 into 3, 2 into 4, like that. So that is why multiples are infinite. Dot, dot, dot means we can keep writing. For 4, multiples are 4, 8, 12, like that, we can keep writing. But what about factors? Factors are finite. It's limited. We can count. But multiples, we can keep multiplying. And I can multiply 2 with 100 also. 2 into 100, 200. 2 into 1000, 2000, like that. So multiples are infinite. Okay. Next, what is HCF? What is highest common factor? See, this technique we use only for understanding purpose. We are not going to use this technique to do the question in the exam. If you do this technique, you'll get 0. Okay. This technique which we learned in the class is only for understanding purpose. Okay. So suppose if I have two numbers 6 and 12. What are the factors of 6? 1, 2, 3 and 6. What are the factors of 12? 1, 2, 3, 4, 6 and 12. What are the common factors? See, first of all, we listed out the factors. What are the common factors? 1, 2, 3 and 6. In these factors, which is the highest? 6. That is why HCF, bracket means off. Okay. Bracket means what? Bracket means off. So HCF of 6 and 12 is 6. HCF of 6 and 12 is 6. What we learned? What is a factor? Factor is an exact divisor. What is factor? Exact divisor. That means 1 can divide 6, 2 can divide 6, 3 can divide 6, 6 can divide 6, right? 1 can divide 12, 2 can divide 12, 3 can divide 12, 4 can divide 12, right? And 6 can divide 12, 12 can also divide 12. Correct? So factors means they can divide, right? Now, 1 can divide both, 2 can divide both, 3 can divide both, but 6 is the largest number which can divide both. You can observe very carefully here. 1 can also divide 6 and 12. 2 can also divide 6 and 12. 3 can also divide. But 6 is the highest common factor which divides the given number. So we can also say that HCF is the largest or the greatest. Sometimes they will use the word greatest also in the question. So HCF is the largest or the greatest number which divides the given number. What is HCF? Largest or the greatest number. Why we teach this technique? To make you understand that HCF is the largest number which divides the given number. See, 1 can also divide. 2 can also divide this. But HCF is the largest number which divides. Clear everyone? Yes or no? Very important statement is, okay, this one you have to remember. Okay. Next we learned, again I have given another example here. Next, LCM, least common multiple. So for 2, I'm writing multiples of 2 first. 2 1s are 2, 2 2s are 4, like that I keep writing multiples. For 3, I've written multiples. Next, I take the common multiple. Which are the common multiples? 6 is common, 12 is common, 18 is common. And if you keep writing, no, even 24 will be common. Actually, 24 will come in the multiple of 2. Na? So many other multiples will be common. Which is the lowest in that or the least in that? That is 6, right? See, if you write the multiples of 2 and the multiples of 3, there will be so many common multiples. 6 is there, 12 is there, 18 is there, 24 is there, even 30 is there. Okay, so many common multiples will be there. See, 30 will come here also and here also. 30 is also common only. But which is the smallest which is common? Which is the least which is common? 6. That is why LCM of 2 and 3, LCM bracket means off. LCM of 2, 3 is nothing but 6. Clear everyone? Yes. So if you observe carefully, LCM, see, LCM we are taking multiples. Now if 6 is a multiple of 2, 6 will be divisible by 2 for sure. Because when we are doing division, we are seeing multiple on 2 3s or we are taking multiple of this divisor, right? Yes or no? When we are doing the division, we are taking multiple of this, not 2 3s. So multiple will be divisible by the number. Please remember, multiple. All the multiples will be divisible by 2. All these multiples will be divisible by 3. Okay. Now common multiples will be divisible by both. Common multiples will be divisible by both, right? Yes or no? Multiples will be divisible, not divide. Divide and divisible both are not same. That is why actually here I stopped Sawmill and actually made it very clear that divisible and divide both are not same. Okay. So here LCM is divisible. Divisible by what? Divisible by 2 and 3. So LCM is the smallest number which is divisible by the given number. Okay. LCM is the smaller which is divisible. But what about HCF? Is the largest number which divides. See, this is dividing these two. This is dividing both. See, this is not divisible. See, if you observe carefully, 6 is not divisible by 12. 6 is not divisible by 12. 12 cannot divide 6. Yes or no? Yes. Yes. Just 1 minute. Okay, sorry everyone. Okay. So if you look carefully, 6 divides both these numbers. Okay. 12 cannot divide. Please remember. So HCF divides. LCM is divisible. Actually, I have made all this very clear during the regular classes. Okay. You please revise all this. Okay. Yes. LCM is the smallest number which is divisible by the given numbers. Okay. LCM is the smallest number. This is the smallest number. See, even 12 is divisible by 2 and 3. Okay. Even 18 is divisible by, but 6 is the smallest number which is divisible. Okay. So remember, HCF divides, LCM is divisible. That's all. Okay. Next, moving forward, we discussed fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Every composite number can be expressed or factorized, we can say, as a product of primes. And this factorization is unique apart from the order in which the prime factors occur. Now, to explain this particular statement, I have taken some numbers. Okay. For example, I have taken 6. 6, I can write 2 into 3. I can take 6 and write 2 3s are 6, 3 1s are 3. So 6 is 2 into 3. Now somebody can do like, start with 3 also, 3 2s are 6, 2 1s are 2. So 3 into 2. Yes or no? See, order is different. Here 2 into 3, here 3 into 2. Order is different. But the prime number, see, here also I have 2, here also I have 2, here also I have 3, here also I have 3. Correct? So prime numbers are same only. Order is different, but prime numbers are not going to change. So every composite number, even 6 is a composite number. Well, how do I know 6 is a composite number? Because it has more than 2 factors. More than 2 means 3, 4, 5, 6 like that. More than 2. So every composite number we can express like this as a product of primes, and this factorization is unique. Why do we say this factorization is unique? What is factorization? Writing a given number as a product of prime. That is prime factorization. Okay, writing a given number 6, we are writing as 2 into 3. 2 and 3 are both are prime numbers, right? So it is called as prime factorization. So if you see the factorization it is unique. Why it is unique? Because always 2 and 3 will only come. Whatever way you do, for 6, 2 and 3 will only come. That is why we say it is unique. Apart from the order in which the prime factors occur. Yes or no, everyone? Understood? Yes? Perfect. So here we have used prime factorization method. I mean, we are just prime factorizing. Okay. We are just taking the numbers and doing the prime factorization. Okay. So if you take 8820, look here, everyone. I'm writing 8820 as a product of primes. How do I do that? See, whenever we are doing prime factorization, we always have to divide only by prime numbers. Please remember, whenever we are doing prime factorization, we always have to divide by prime numbers. And what are prime numbers? We have 2, 3, 5, 7, 11, 13, 17, 19, and so on. Okay. I mean, generally we'll not need higher prime numbers. Mostly it will not come. Okay. But it comes. Okay. Rarely it comes also, but mostly it will not come. Okay. Now, whenever we are doing prime factorization, no, my humble request, always start from the smallest. Okay, I mean, as soon as I see 0 here, most of the students will start dividing by 5. That is also correct, but don't do it. Start with 2. Then if it is not possible by 2, go with 3. If it is not possible by 3, go with 5. And keep going in that order. Very important, always go in order. Why? You will actually, avoid making mistakes. Okay. From my experience, I'm saying you will avoid making mistakes. Okay, if you do that way. Okay. So now this is divisible by 2. How do I know that this is divisible by 2? We have learned the divisibility rules also. If you want to check if a number is divisible by 2 or not, the unit place digit, the digit here should be 0, 2, 4, 6, 8. If the number is having 0, 2, 4, 6, 8 in the units place, or from the right, no, the first digit, that is called unit place digit. If it is having 0, 2, 4, 6, 8, it is divisible by 2. How to check for 3? If the sum of the digits, see for example here, it is having 5 now. It is not having 0, 2, 4, 6, 8. So this is not divisible by 2, right? Yes or no? Now, if it is not divisible by 2, you go to the next number 3. How to check if this number is divisible by 3 or not? You add the digits 2 plus 0 plus 2 plus 2 plus 0 plus 5. It will be 9. Now 9 is divisible by 3. That is why this number is divisible by 3. So if the sum of the digits is divisible by 3, then the number is divisible by 3. Okay, how to check with 5? The number should end with the digit 0 or 5. If a number is ending in 5 or 0, it is divisible by 5 for sure. Okay. For 7 also we have a rule actually, that is not required. Okay. For 7, actually I think so I have told in class also. Okay, we remove the last digit. Okay, you double it, subtract from the remaining digit. And if the remaining, if you subtract from the remaining digit, if you get 0 or a multiple of 7, if it is divisible by 7, then the number is also divisible by 7. Okay. Fine. So now, I'm starting with 2. 2 4s are 8. 2 4s are 8. That is why 2 4s are 8. 2 4s are 8. 2 1s are 2 and 2 zeros are 0. And then again 2 2s are 4. 2 2s are 4. Now look here. All of you, please focus. Here, a lot of students will make a mistake. Okay. 1 is not divisible by 2. Please listen, everyone. Just 1 minute. Please listen here, everyone. So 4 is divisible by 2. So 2 2s are 4. 2 2s are 4. Correct. Now 1 is not divisible. To take the next digit, you put a 0 first. To take the next digit, you put a 0 first. Very important. Many students will not put the 0. Okay. Then 2 5s are 10. Okay. Next, it is not divisible by 2. So you go with 3. First you check. So it is, we already checked, right? So 3 7s are 21, carry over 1. Because 21, 22. We have 22, right? 3 7s are 21, 22. So 1 carry over. 3 3s are 9, carry over 1. 3 5s are 15. And then again, 7 plus 3, 10 plus 5, 15. Yes, we can do again with 3. 3 2s are 6, carry over 1. Because 7 is there, no? 3 2s are 6, 7. Okay. So next, 3 4s are 12, carry over 1. 3 5s are 15. We have discussed all these in detail in the classes. I expect everyone to know all this, okay? You should actually revise the class notes thoroughly before joining the class, okay? Because everyone has attended the regular classes, okay? You have to revise and come. Quickly, we'll see each of them, okay? And then we'll solve questions, okay? We cannot see each and every concept in depth. It is not possible, okay? So same way I have done this also. You should practice all this. You should practice and come. Okay. 2 5s are 10. 2 zeros are 0. 2 4s are 8. 2 2s are 4. Carry over 1. 2 5s are 10. 2 2s are 4. 2 1s are 2. 2 2s are 4. 2 6 are 12. 2 6 are 12. 2 3 are 6. And then we keep doing, right? Right? So we are writing the number as a product of prime. Now we have used power form so that it is easy for us. Why power form? How power form? Look here. 2 is 2 times. So 2 to the power 2. 3 is 2 times. So 3 to the power 2. You know all this, right? Yes. Same way here. 2 is how many times? 4 times. 2 to the power 4. Like that I have written. Okay. Yes. Now, so I wrote those two numbers as a product of primes. You see, only prime numbers we have 2, 3, 5, 7, 2, 3, 7. So these are prime numbers, right? So that is why it is called as prime factorization. That is why it is called as prime factorization. Okay. Now I want to find the HCF. Okay. Please remember the rule. Whatever we learned earlier, no, the conceptual understanding, that is not going to help to find the HCF by the prime factorization. To find the HCF by the prime factorization, the rule is a bit different. Okay. What is the rule? We are going to see the common factors first. 2 is there in both. 3 is there in both. 5 is not there in both. Common means it should be there in both. Okay. 7 is there in both. Okay. So to find the HCF, first of all, you see the common factors. Okay. And write that. 2 you write, 3 you write, 7 you write. Then you take the smallest power of the common factors. Okay. For 2, what is the smallest power? 2. So you write 2. For 3, which is the smallest power? Both are having 2, you can write 2. For 7, smallest power is 1. So write 1. So please remember, for HCF, what we do? Product of smallest power. We take the smallest power of each common prime factor. First, you take common prime factor and take the smallest power of each of the common prime factor. Okay. They have used this statement in one of the assertion reasoning question. Exact same statement they have used. And many people were confused. What is this? Okay. So product of smallest power. See, don't think that this means we are multiplying the powers. It's not like that. You have to read the entire statement. Product of the smallest power of each common prime factor. So first you take the common prime factor and take the smallest power and then multiply them like this. Common, smallest power. Okay. See, with lot of practice, I mean, you can just take the common prime factor and put the smallest power in the first step itself. Initially, because I want to teach a proper way, so I tell take the common first, put the smallest power, then multiply. Okay, with practice, you will automatically take it, okay, in single step itself. For LCM, what do? For LCM, we don't see common. For although we have least common, but that is why I told the prime factorization technique is a bit different. Okay. Whatever we learned was a bit, I mean, for conceptual understanding. So in LCM, what do? You take every prime factor. In LCM, we take every prime factor with the highest powers. See, in this one, 2 is there, 3 is there, 5 is there, 7 is there. So you write everything, 2, 3, 5, 7, and put highest power of each of them. Put highest power of each of them. Okay, and then multiply. What is the meaning of 2 to the power 4? 2 to the power 4 means 2 into 2 into 2 into 2. 3 to the power 2 means 3 into, some people will do 3 to the 6 also. There are some students who are doing like this also. 3 to the power 2 means 3 into 3, not 3 into 2. Please remember, I am telling this. Okay, and then you multiply, you will get the LCM. Clear everyone? Yes or no? Perfect. So what we are doing in the LCM? Product of greatest power of each prime. Here no common. See, common is only in HCF, but there is no common here. See. So product of greatest power of each prime factor involved in the numbers. Okay. Now, suppose I have two numbers A and B. Suppose I have two numbers A and B, or you can take X and Y also, anything. Suppose I have two numbers A and B. If you find the HCF of those two numbers, and if you find the LCM of the same two numbers, A and B, you are taking two numbers A and B, you are finding HCF of that and LCM of that. If you multiply HCF into LCM, it will be the same as product of the numbers A and B. It will be the same as what? Product of the numbers. HCF of two numbers into LCM of the same two numbers is equal to product of the numbers. So HCF of x into y into LCM of x into x comma y, sorry, is equal to x into y. Clear everyone? This is applicable only for two numbers, not for three numbers. This is applicable only for two numbers. HCF of two numbers into LCM of the same two numbers is equal to product of the numbers. Okay. Very important relation. Okay. Very important relation. Okay. Based on this, they're asking a lot of questions as well. Okay. So we have done some question to prove that. Okay, next here I have taken 6 and 20. How do I find the HCF and LCM? You take 6, first of all, express the product of primes like this: 2 into 3 to the power 1, 3 to the power 1. 20 is 2 to the power 2, 5 to the power 1. For HCF, what do? We take only common. 2 is only common and put the smallest power. So 2 is the HCF. LCM, we take all the prime factor, put the highest power. 2 highest power 2, 3 highest power 1, 5 highest power 1, multiply 60. So if you see, HCF of 6, 20 is 2. LCM of 6, 20 is 60. If you multiply HCF and LCM, it will be the same as multiplying the two numbers 6 and 20. 6 into 20 is 120. HCF is 2, LCM is 60. Multiply 120. So both are equal. Clear, everyone? Yes. So now this is not applicable for three numbers. Whatever we discussed now, it is applicable only for this relation is only for two numbers. Okay. But we can find HCF and LCM for three numbers. Okay. We can find HCF and LCM. Okay. So how to find? We have done another example. Take the numbers, express as a product of primes, and then for HCF, take only the common, put the smallest power. Okay. So 2 smallest power 1, 3 smallest power 1. For LCM, take all the prime numbers and put these highest powers and multiply, you'll get the answer. And then we have done some MCQ questions. Okay. In the class, same way. Total number of factors of a prime number. What is a prime number? Exactly 2 factors. So total number of factors of a prime number will be 2 only, right? Yes. Then here they're asking HCF and LCM of this one, so we have found out. Okay. See, when it comes to MCQ, we can use any technique. Any technique. We have common division method also, right? For HCF and LCM, you can use that also. But if it is a theory question, you cannot use any other technique except prime factorization. I'm saying this again. If it is a theory question, you cannot use any other technique except prime factorization. Clear? Use only prime factorization. Remember that. See, we have done this question also. LCM of smallest 2-digit composite number and smallest composite number. We have done this question in the class itself. So smallest 2-digit composite number is 10. So read the question and do it carefully. Okay. Next. First of all, we'll cover all the concepts. Okay. And then I'll give you questions. Okay. So we have done this question also. If x into y, x and y are numbers. Okay. How do I know? Because they're asking LCM of x comma y. So obviously they are numbers only. Okay. So x into y is 180 and HCF of x comma y is 3. Then find the LCM. We know that HCF of x comma y into LCM of x comma y is equal to x into y. X into y is 180. HCF is 3. LCM we want to find out. So this is a variable for us. LCM is what we want. So that is a variable for us. So we'll take 3 to the right side and we'll get 60 as the answer. Clear, everyone? Very nice. Okay. Just now, we have learned the prime factorization technique. Okay, just now we have learned the prime factorization technique. What did we learn in that? If you take 18, I can write 18 as 2 9s are 3 3s are 3 1s are. That means I can write 2 to the power 1, 3 to the power 2. Yes or no? Every composite number I can write as a product of prime. Every composite number. Okay. Every composite number I can write as a product of prime. Now, in the question, they will say that P and Q are prime numbers. They will say in the question, they will mention P and Q are prime numbers. Okay. P and Q are prime numbers. See, if P and Q are prime numbers, that means A and B will be composite number. How do I know? Because composite number only we can write as a product of primes now. Composite number only we can write as a product of primes now. Yes or no? So if they give P and Q are prime numbers, that means A and B are composite number. So A, how have they written? P square Q, P to the power 2, Q to the power 3. And what is B? P to the power 7, Q to the power 7. So instead of P, now some numbers will come. Maybe 5 can come, maybe 7 can come. Some numbers will come. Okay. Here P and Q they have given as a variable. Okay. But P and Q are some prime numbers. Okay. So P and Q are prime number, but A and B are composite number. So if you want to find HCF of A and B, what do? You take common. Common is P also, Q also, and put smallest power. So 2 and 3. So P to the power 2, Q to the power 3 is the HCF. Yes or no? And for LCM, what do? You don't take common. Although here we have only common. Here both are common, but we don't take common in LCM actually. Okay. We take all the prime factors or all the prime numbers and put the highest power. So P power 7, Q power 5. That is the LCM. Clear? So sometimes they're asking questions in variable form also for HCF and LCM. Okay. So, practice. So we have done this question in the class. Okay. So they had told that if two positive integers A and B are written as A is equal to this one and B is equal to this one, where X and Y. So here they're saying X and Y are prime numbers. So A and B will be definitely composite only, right? Because composite only you can write as a product of primes, correct? Then the result obtained by dividing product of the positive integer. Which are the positive integers? A and B. So they're asking result obtained by dividing the product of the positive integers. So A and B are the positive integers. So the result obtained by dividing product of positive integers by the LCM of A comma B. By the LCM of A comma B. So LCM of A comma B will be what? A is this one, B is this one. LCM, what do? You take all the prime numbers and the highest power. So X power 3, Y power 3. That is the LCM. Yes. X power 3, Y power 3. What is the product? A into B. So you have to multiply these two. So when you multiply and simplify, here I have done it. Look here. See, LCM is you put the highest power of all the prime factors occurring, and product will be you have to multiply these two because A and B are those two only, right? So if you simplify, you will get the answer y square x, that means xy square. That is option B. Clear, everyone? Now, before you come for the class, you please go through all these questions, practice and come. Okay. So that we don't have to spend much time. We can quickly revise the concepts and start doing the other questions, because if we do the same question, then there's no use of revision. Okay. We should do some different questions, okay, for practice. So all this again, if I am teaching for 1.5 hours, what is the difference then? There's no difference, right? You please revise and come. We'll just quickly recall everything and then we'll start doing, okay? So all these things I should not be teaching again. Okay. You should practice. If you have doubts, you can watch the recording because all the recordings are available in the Google Classroom, right? You can watch the recording. If you have any other, if you still face, some difficulty in understanding, you can always ask me. Okay. Yes. Now, for all the assertion reason question, all the 4 options will always remain like this only. Okay, they will not change. So I request everyone to learn it. I had actually requested this long back when I had taken this lecture. On 18th of April, I have taken this lecture. So I had told everyone to learn all this. Okay, so please learn. All the 4 options you have to learn. When I'm giving a test, I will not give these 4 options. You have to learn and come. For assertion reasoning, I will not give these 4 options. I will give the 2 statements. You have to A, B, C, D, you have to choose. Okay. So A is both assertion and reason are true, and R is the correct explanation of A. Here, R is not the correct explanation of A. A is true, R is false. A is false, R is true. Okay. So we had done all this question. Okay. Next, we had learned another concept. Generally, they ask this kind of question also. What problems? Find the largest or the greatest number which divides 6 and 20, leaving no remainder. Now, here generally students have confusion what to find out, HCF or LCM. So, greatest number which divides. We know, right? HCF divides. LCM is divisible. So, greatest number or the largest number which divides will be nothing but HCF. Now, one more thing. You cannot just find the answer and expect full marks. It will never ever come. You have to write the steps like this. First of all, you have to say that the largest number which divides 6 and 20, leaving no remainders, is nothing but HCF of 6, 20. Then you use the prime factorization, find the HCF, and write the conclusion. Introduction and conclusion is mandatory. Clear, everyone? So if you want to find the largest or the greatest number which divides, leaving no remainders, we have to find the HCF. Okay, here also another question. You can use this for practice. Similar I mean, similar concept. Numbers have changed. Okay. Next, find this smallest. See here largest, here smallest. Find the smallest number which is divisible. Here it is divisible. LCM is divisible. LCM is divisible. So smallest number which is divisible is the LCM of these three. So you write that is the first line. The smallest number which is divisible by is LCM. Then you find the LCM, and whatever answer you get, you write the conclusion. Clear, everyone? Very nice. So we have done another question. You can just practice. Now here, earlier there were no remainders. Okay, there were no remainders earlier. See, leaving no remainder, leaving no remainder. But now we have questions where they will say, find the greatest or the largest number which divides these two, leaving remainders 5 and 8 respectively. That means what? When you divide 70 by that number, you will get remainder 5. If you divide 125 by the greatest number, you will get remainder 8. I repeat, the question is, when you divide 70 and 125 by the largest number, remainder will be 5 for 70 and 8 for 125. When you divide 125, you get 8. So that is why respectively they have used. So how do we do this question? See, in this, I have explained all this in detail in the classes, but I mean, just quickly I'll tell you, for all these questions now, you remove the remainders from both of, I mean, from each of them, and then find the HCF. Okay? Because, I mean, for example, okay, I have given some examples also here. Otherwise, let me give another example. Suppose, for example, I have 27. Okay? 27, okay? And suppose I'm dividing by 5. Okay? So 5 5 is 25, remainder is 2. See, if I remove this remainder from 27, then 27 will become divisible. Yes or no? See, 27 is not divisible by 5 because remainder is 2. Yes. If I remove the remainder from the 27, then number will become divisible. Same way, these numbers are living remainders. They are living remainders. See, 27 is living remainder 2 when I am dividing by 5. So if I remove 2 from 27, it will become divisible. Same way, 70 and 125 are not divisible. They are giving some remainders. If you remove those remainders, no, it will become divisible. It will become divisible. Okay. So largest number which divides 70 and 125 living remainders will be, you have to find HCF by removing the remainders, and that will give you the answer. And you can cross check also. If you divide 70 by 13, you'll get 5 as a remainder. If you divide 70 by 13, you'll get 5. And if you divide 125 by 13, you'll get 8 as a remainder. Clear, everyone? Yes. Then the smallest number or the least number which is which when divided. So LCM is divisible, right? So here when they ask a question, leaving remainders, we follow a different, I mean, set of procedure. For LCM, whenever there's a remainder, what we do is, first you find the LCM. And to the LCM, you add the remainder. Okay. Look here. I mean, I have explained this in detail in the class also. See, here we want to find the smallest number, which is which when divided by all of these will leave remainder 6 in every case. Okay, that means when you divide by 12, you'll get 6 as a remainder. If you divide by 21, you'll get 6. If you divide by this also, you'll get 20. You'll get 6, right? So to find that, what we do now, see, we know that you forget about this one. Okay, look here. All of you look here. You forget about this remainder thing. Okay. The smallest number which when divided by will be what? The LCM. So you first find the LCM. If you want remainder, you add that number. See, for example, let me take 25. Okay. Now 25 is divisible by 5. If I want remainder 2, you add that remainder. 27 will leave remainder 2 if I divide by 5. I'm repeating again. 25 is divisible by 5. If I want remainder 2, I will add remainder 2 to this 25. I will get remainder 2. Yes or no? Same way, the smallest number which is divisible is nothing but LCM. LCM is divisible. Correct? Now, if you want remainder 6, you add 6 to the final answer. To the LCM, you will get the answer. So 426 is the answer. You find the LCM and add 6 to that, you will get the answer. Clear, everyone? Yes. Next, we have done some other word problems, very frequently asked. Okay. I've given a detailed explanation of all this during the regular classes. Okay. We have learned this in detail. So I had told, and Stuti is not there today. Actually, she was telling me that just because I have told all these techniques, she finds it very she finds it very easy to actually approach the word problems. Okay. She's having exam, that is why she has not joined. Okay. So please, try to solve more questions so that you get clarity. Okay. So here, 3 alarm clocks rings at interval of 4, 12, 20 minutes respectively. If they first ring at 6 a.m. together, at what time will the next ring together? Okay. So now how do we do this kind of question? See, whenever there is a case of repetition, something is repeating. Okay. Then we always find the LCM. Please remember, whenever something is repeating, okay, we find the LCM. Now look here, there are 3 alarm clocks. I have taken an example to make you understand. There are 3 alarm clocks, P, Q, R, for example. Okay. Now P, the first alarm clock, rings at an interval of 4 minutes. That means what? If it is starting at 6 o'clock, next it will ring at 6:04, 6:08, 6:12, 6:16, 6:20, 6:24, 6:28, like that. There are 3 alarm clocks which rings at an interval of 4 minutes, 12 minutes, and 20 minutes. Okay, so first one will ring every 4 minutes, second one will ring every 12 minutes, and third one will ring every 20 minutes. Okay. If they first ring at 6 a.m., all of them know, first they ring at 6 a.m., all of them. And after that, they will ring, first one will ring every 4 minutes, second one will ring every 12 minutes, and third one will ring every 20 minutes. Okay. So if they first ring at 6 a.m. together, at what time will they next ring together? Okay. All of these should ring together. See, first one is ringing at 6:04, 6:08. After all of these, there are 3 alarm clocks. After they ring at 6 a.m., the first one will ring only at 6:04, then 6:08, like that. They're asking when will they next ring together. All the 3 should ring together. So that will actually happen. One minute, I'm not able to erase one. Thing has happened. It's okay. Sorry. So if you observe carefully, right? See, in all of these, when actually the first alarm clock is ringing, I'm actually writing the multiple because 6:46, like that. It'll ring 60 here, 60 here, 60 here. And we are taking minutes, right? And 60 minutes is 1 hour. So if they're ringing at 6 a.m., 7 a.m. again they will ring. Yes or no, everyone? But all these things we should not do in the exam. This is only for you to, understand. You should not do all this in the exam. This is only for understanding. In the exam, we have to actually follow this technique. Okay. You have to say that the 3 alarm clock will ring together at LCM of these 3 numbers. So you find the LCM by the prime factorization and you just say that they will ring together again in 60 minutes. That is at 7 a.m. Because 6 a.m., 60 minutes is 1 hour. So 7 a.m. it will ring together. Clear, everyone? Perfect. Again, similar question. 3 bells toll at this much time minute respectively. If they start tolling together, at what time will they next toll together? Next ring, toll means ring. So it will be the LCM we have to find. Okay. Write the introduction, write the conclusion. Very important. Okay. We had another question. See, all of these questions, please practice and come. Okay. Almost everyone has written the class notes. So you revise those class notes and practice the question. Please. Okay. So 3 bells are there. They are ringing at interval of 60 seconds, 90 seconds, and 125 seconds. If they ring together at 1 p.m., then at what time will they ring together again? So write the introduction, find the LCM. Now LCM will come in seconds, right? Now they're asking time. 1 p.m. they have given, so they want time. You cannot write only 4,500 seconds. If you write this, you'll lose marks for sure. Maybe half marks or 1 marks, they will definitely cut. They also want time. They want time. So you have to convert this seconds into, minutes, okay, so that you can tell the exact time, okay. So you know that 60 seconds is 1 minute. So 1 second will be 1 by 60 of a minute. So 4,500 seconds will be 75 minutes. And 75 minutes I can write as 60 plus 15 because 60 minutes is 1 hour. So I am writing this way because it is more than 60. That is why I am writing. So 1 hour 15 minutes. So if they are ringing at 1 p.m., next they will ring at 2:15 p.m. Clear, everyone? Yes. Next. We have done all these questions. Okay. Find the HCF and LCM by the prime factorization method. See, all these are being asked in the board exam. Whatever we have done in class also, all these are being asked in board exam. Okay. So I mean, look here. This is how we do. Okay. Next, we have done some few more word problems. So this is also a repetition case. So we find the LCM and we get the answer. On a morning walk, this is also a very important question. It has been asked in the board also. So here also, I mean, on a morning walk, 3% step off together and their steps measured. I have explained you what is the meaning of complete steps and all. You can watch the recording itself of the class if you don't understand this. Okay. Okay. Then we have done this question also very important. Okay. A college conducts a seminar for various subjects. The number of participants for English, maths, and science are 60, 84, and 108 respectively. Every room has to accommodate equal number of participants. Find the number of participants in each room. So here we have some participants actually for English, maths, and science. They have given some numbers. Okay. They want to find the maximum number of participants in each room. They want to separate. Okay. So for that, we have to actually, I mean, here we have to distribute in such a way that you have equal number of participants in each room. Although they have not given, wait, have they given equal number? Actually, it has to be equal number in all the rooms also. Find the maximum number of participants. See, this is not a case of repetition and all, I mean. And here, generally, whenever it is distribution, right? Whenever we are distributing something or arranging something, mostly we find HCF. Okay. So yeah, one more thing you can remember, no? I was just going through some resource, and actually I just learned from there that, I mean, whenever you read the question and you find that the answer will be more than the number. For example, let me just show you 1 minute. Okay, let's come to this question. Okay. Wait. Let's look at this question. 3 bells are there. They are ringing together at 9, 12, and 15 minutes respectively, right? If they start calling together, at what time they will next call together? So our answer will be more than all of these numbers. It will be more than 15 minutes. It will be more than 12. Yes or no? I mean, see, this bell will ring only after every 15 minutes. So answer cannot be less than 15. Yes or no? Yes. So whenever the answer is more than the individual numbers, no, whenever the answer is more than the individual numbers, you have to find LCM. Okay. Whenever the answer is more than the individual numbers, you have to find LCM. First thing you remember, repetition case. Whenever repetition is there, we have to find the LCM. Another thing which you can remember is whenever the answer is more than the individual numbers, okay, you will find out after reading the question. Then you have to find the LCM. Okay. So here, if you look here. So a college is conducting a seminar for various subjects, right? So the number of participants for English, we have 60. For maths, we have 84. And for science, we have 108. Every room has to accommodate equal number of participants. So in every room, we have to have equal number of participants. So find the maximum number of participants in each room. See, in each room, okay, can we have, I mean, more than 108 participants? Can we have? We cannot have, right? We cannot have more than 108 participants in a single room. Okay. So for this reason, I mean, because our answer is going to be less than that, okay, we just find the HCF. Okay. So HCF of these three will actually give us 12. That means in each room, we have maximum 12 participants. Actually, there's some more condition given in this question. I don't know why it's not present here. Maybe I have taken this from some resource or what. Maybe there's some more condition attached to this question. Okay. It was there in the board when I was seeing, right? There's some more condition attached. Okay, that will give us more clarity that we have to find only HCF. Okay. How many rooms are required? See, we know that in each room, maximum 12 participants can come. In each room, maximum 12 participants can come. So how many rooms will be required? See, 60 we have for English. So 60 by 12 will give us 5. So 5 rooms, especially for people who have come, who are English, participants who have come only for English. Yes or no? Next, for maths, again you divide 84 by 12. Okay, 7. So 7 rooms for maths and 1 audit. Okay, that is 9. Okay, clear everyone? So how many rooms are required? 9 plus 7 plus 5. Clear everyone? So we have done that also, okay. Otherwise we can do, see, one way is this, another way is you can divide the total number of participants by 12, you'll get number of rooms. And then they have asked the LCM of these 3 separately, so you can find. Clear everyone? Yes. See, if you add this also, 7 plus 5, 12 plus 9, 21 will only come. Okay, 21 rooms. Okay. Yes. Okay, next. So this one, I had explained this question. I had explained this concept that HCF is always a factor of the LCM. Okay, look at you look here also. Right. Look here. We have found HCF and LCM. Is 3 a factor of 420? 3 can divide 420, no? So 3 is a factor. Yes or no? Look here. Is 6 a factor of 360? So HCF will always be a factor of LCM. Always. HCF will always be a factor of the LCM. And so we can say LCM will be a multiple. See, LCM is a multiple of this, right? Yes or no? You can say LCM is a multiple of factor or HCF is a fact. I'm sorry. LCM is a multiple of the HCF. Yes. Or HCF is a factor of the LCM. Clear everyone? I'll write that. For clarity. HCF is a factor of LCM, or we can say LCM is a multiple. LCM is a multiple of the HCF. Clear? It's a multiple of 3 now. 420. It's actually like 3 140. No, not 140. I'm sorry. Correct. 140. 140. 3 into 140 will give you this. Yes or no, everyone? Yes. Okay. Next, we have this kind of questions which is being asked. Check whether 4 to the power n can end with the digit 0. See, earlier, no, when the pattern was a bit different, they used to ask sometimes this question for 4 marks. Okay, you can, if you check, before 2023, okay, they have asked this kind of question for 4 marks also. They have done that. Sometimes for 3 marks also they have asked. Okay, sometimes for 2 marks also. Okay, recently they had asked for 2 marks. Okay, but anyway, there's a standard way in which we write the answer for these questions. Okay, so we have to check whether 4 to the power n can end with the digit 0 for any natural number n. Now, see, before you answer this question, we have learned the concept that whenever a number is ending in 0, 2 and 5, I'm saying and, okay, 2 and 5 will definitely be a factor. And, okay, it is not 2 or 5, I'm saying 2 and. Both will be there. If a number is ending in 0, then 2 and 5, okay, 2 and 5 will definitely be a factor. Okay. If 2 is not there, only 5 is there, then the number will not end with 0. If 2 is there, 5 is not there, then the number will not end with 0. If 2 and 5 both are there only, the number will end with 0. Clear, everyone? You can see 10, if you take 2 and 5 is there, no? 2 into 5 I'm writing. Okay. So we are actually seeing this, we have seen all this in detail, okay? Please go through. I mean, if anyone is actually facing some difficulty, you can always watch the recording. You can go to the Google Classroom, okay? Everyone knows how to access, okay? You have been attending classes for, I mean, since March, so you know the process, okay? You just go to the Google Classroom, watch the recording. I mean, you can, wherever you get stuck now, I mean, if you feel that, okay, you need to understand that again, you can go to that particular part alone, okay? See, for example, I'm having lecture 3. This is lecture 3, right? This is lecture 3. So suppose, for example, I'm not able to understand, maybe this one I'm not able to understand. For example, this one. So when I have taken, I mean, in middle, it's actually after this. So accordingly, you can fast forward the video. I mean, you can go to that particular place where this question starts and you can start watching the recording. Okay. So for example, I'll show you. Okay, I'll share my screen. Okay. So, I mean, suppose the recording, real numbers is there, no real numbers. So in the Google Classroom, you have to go to classwork. Okay. And go to real numbers and click on this. Once you click on this, the playlist will open and you can click on lecture 3. Okay. Okay, it has opened like that. It's just 1 minute. Namaste, everyone.
Namaste, sir.
Namaste, sir.
Namaste, sir. Yes.
Meet again 45. So, okay. See, suppose if I have 2, 4, 6, okay. Look, everyone. So you can actually understand, I mean, if by watching this also you can understand, okay. If you have doubt in any particular part, you can watch this, okay. I have explained in detail. Okay. Yes. Perfect. So let's come back to this. So I'll come back to this. Okay. So how do we answer this question? So first of all, you please learn the procedure. I mean, learn the steps. Okay. You will start with the number 4 to the power n for any n. N is a natural number. Okay. For any n were to end with the digit 0, then it would be divisible by 5. Why 5? Actually, both 2 and 5, but here they have given like this. We'll proceed this way. Okay. This one is actually from the answer key of CBSE. You can exactly follow this way. Okay. See, we know the concept. If a number is having 2 and 5 only, it will be ending with 0. We know that. But since they have given this way, we'll follow it. Okay. So if a number 4 to the power n, for any n were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 4 to the power n would contain the prime number 5. This is not possible here. See, actually 4 to the power n, no, it is not having 5. That is why they have started this way. Okay. Because 2 is already there. In 4, see, look here, 4 to the power n means 2 into 2 to the power n. 2 into 2 means 2 square. So I can write 2 to the power 2n. So 2 is already there, 5 is not there. So that is why they have started like this. Okay. So for if a number 4 to the power n for any n were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 4 to the power n would contain the prime number 5. This is not possible here. Okay. Why it is not possible? Because you write this way and show it to them. So the only prime in the factorization of 4 to the power n is 2. And the uniqueness of fundamental theorem of arithmetic guarantees that there are no other prime factors there are no other primes in the factorization of 4 to the power n. So there is no natural number n for which 4 to the power n end with the digit 0. Okay, because 5 is not there, no, it will not end with the digit 0. Only 2 is there. Okay. You cannot use some other technique, some other way to write. Please use only these lines. Okay. These are the standard lines. You please use this way. Okay. Next, state whether 6 to the power n can end with the digit 0. Again, here, same. Everything is same. Just the prime factorization is a bit different. Here 6 is there, so they have done it a bit different. But steps, you see, same only. Everything is same only. Yes or no, everyone? So please follow this way. Okay. Check whether 12 to the power 12 to the power n can n. We have done this in teacher in the class. Okay. If you have any doubt, you can just watch it. Pause the recording of the class also. Okay. You have time, you can watch it. Okay. State whether 20. See here, 20 to the power n can check whether 20 to the power n can end with a 0. We know it is ending in 0, right? So how do we write for this cases? We'll say that if the number 20 to the power n for any n were to end with a 0, then it would be divisible by 5. That is, the prime factorization of 20 to the power n would contain the prime number 5. This is possible because 20 to the power n is 2. I can write 20 as 2 tens are, 2 fives are, 5 ones are. So 2 to the power 2, 5 to the power 1. So using the laws of exponents, we write like this. So the primes in the factorization of 20 to the power n are 2 and 5. So it is ending with a digit 0. Clear, everyone? So you learn the way we write whenever it is ending with 0 and not ending. You learn one answer. And then accordingly you can modify. Only these will get modified, that's all. Other things will remain the same. Okay. So what is rational number? Next, what is rational number? Any number which can be written in the form of p by q or a by b also we can say. B is not equal to 0. A and b are integers. One more condition is there. A and b are co-prime. What is co-prime? Co-prime is not a single number. Co-prime is a set of number. It is a pair. What is co-prime? It is not a single number. It is a pair. If two numbers have HCF as 1, if the HCF of two numbers is 1, okay, then it is co-prime. Please remember, co-prime does not mean that both the numbers are prime. See, if both the numbers are prime, then also it is co-prime only. But it is not necessary for the numbers to be prime for it to be co-prime. For example, even 8 and 9, they are also co-prime only. 8 and 9 is also, but 8 is not a prime number, na? 9 is not a prime number, na? So it is not necessary for a number to be prime, for both the numbers to be prime, for it to be co-prime. Clear, everyone? Co-prime means HCF should be 1. That's all. Okay. But if the numbers are primes, then also it will be co-prime only. If two numbers, for example, if I take 3 and 5, they are also co-prime also. 3 and 5 are prime, but they are co-prime also. Here also it is co-prime, but they are not primes. So it is not necessary for the numbers to be prime for it to be co-prime. Okay. So co-prime means HCF will be 1. Highest common factor is, here I have given examples also, that 4 and 6 is not co-prime. Whereas 8 and 9 is, here actually I have given examples, right? 8 and 9 is co-prime. Then this is the most repeated question in the exam. 100%, we can say also 100% this question will come. Okay, 100%. But still there are guys, they will not be, they will actually be just learning half-heartedly and they will not get full marks. You know that this question is going to come for sure in the exam. For sure. Okay, it is going to come for sure. You check any paper, instead of root 2, maybe root 3 will be there or root 5 will be there, but this question will definitely be there. Okay. So I expect everyone to learn this standard answer. See, other places there will be some other set of steps. You please follow only these steps. This is properly written. I have taken this also from answer key only. Okay. So to prove root 2 or root 5 or root 7 is an irrational number, we follow the method of contradiction. What do? We follow the method of contradiction. What is method of contradiction? You'll understand when we actually do the proof. See, we want to prove that root 2 is irrational. We want to prove root 2 is irrational. We'll assume opposite to irrational is rational, right? Opposite to irrational is rational. So we'll assume that root 2 is rational. We'll assume. Let us assume to the contrary, to the opposite. Contrary means opposite. Let us assume to the contrary that root 2 is rational. We'll assume. So if root 2 is rational, what is rational number? You can write A by B form. B is not equal to 0. A and B are co-prime. I told you, right? And A and B are integers also. See here, A and B are integers. In rational number, no, these numbers are integers. Okay. So we say, so we can find integers A and B such that root 2 I can write as A by B, where A and B are co-primes and B is not equal to 0. Clear? Clear? Then we are just taking root B to the other side. So B into root 2 it will become B if you take left side. So B into root 2 is A. Then this equation, no, this equation is there, no. We are squaring both the sides. When you square both the sides, no, when you square both the sides, B will get squared. So B square and root 2 square is 2. A will also get squared. So when you square both the sides, you will get 2B square is equal to A square. You have to write this step also. Squaring both the sides, we get. Now, look here, everyone. Please look. Suppose if I am having 6 is equal to 2 into 3. 2 is dividing 6. 3 is also dividing 6. Yes or no? If I write 10 is equal to 2 into 5. 2 will divide 10. 5 will also divide 10. Yes or no? So if I am having 2 into B square is A square. 2 will divide A square. Yes or no? For sure. So if 2 divides A square, 2 will also divide A. For sure. Okay. If, see, for example, 3 is dividing maybe 9 square. So 3 will also divide 9 for sure. So it's like that. Okay. So now, whenever we do division, see 2 divides A, right? Listen here, listen everyone. 2 divides A. A is there, 2 is dividing A. If you divide A by 2, 2 divides, 2 is dividing A. If you divide A by 2, you'll get some number, let it be C. If 2 divides A, if 2 is dividing A, you'll get some number now. You'll get some number now. See, for example, if I am dividing 6 by 2, I will get 3 now. So if you're dividing A by 2, you'll get some number C. A is some number. If you're dividing by 2, you'll get C. So A by 2 will give C. So I can write A is equal to 2C. Yes or no? All these things I've explained in the class also. Okay, it's not like something I'm teaching new. Okay. So we can write A is equal to 2C. For some integer C. What is C? C is some integer. Okay. Now, what we do is we substitute. So you write some equation number for 1. I mean, you write this equation number 1 and write this equation number 2. Okay. So what we are going to do is we are going to substitute A is 2C in this. A square we have no. So we'll put 2C. Wherever A is there, no. You will put 2C. See, when you put, see, I have done the substitution part here. Okay. So left side we have 2B square. Wherever A is there, you put 2C. So 2C square. 2C square means you have to square 2 and C. It will become 4C square. You can cancel 2 2s are 4. So you'll get B square is equal to 2C square. Now if B square is equal to 2C square, that means 2 divides B square. 2 divides B square. So that is why it is written. This means 2 divides B square. So 2 divides B also. Therefore, A and B have at least 2 as a common factor. If you observe carefully, 2 is dividing. Wait. 2 is dividing A. 2 is also dividing B. But A and B are co-prime. A and B are co-prime. Co-prime means HCF is 1. But HCF is what? Largest number which divides. See, if it is co-prime, the largest number which will divide is 1, right? If the numbers are co-prime, the largest number which will divide is 1. Yes or no? Yes. But here, 2 is dividing A and B. That means, therefore, A and B have at least 2 as a common factor. But this contradicts. This is contradicting our assumption. We are assuming that root 2 is rational. We are assuming it is rational. Rational means A and B are co-prime, but here it is not coming co-prime, it is coming as composite. I mean, it is having more than, I mean, it not composite, we can say, because composite we use only for single numbers, it is not co-prime. Co-prime is HCF will be 1. So I'll say it is not co-prime because it is having 2 also as a factor, right? So this contradicts the fact that A and B have no common factor other than 1. We have assumed in the initial stages, we have assumed that, just 1 minute, we have assumed that root 2 is a rational. So it has to be co-prime. A and B has to be co-prime. But here we are getting another common factor. So this is contradicting the fact that A and B have no common factor other than 1. This contradiction has arisen because of our incorrect assumption that root 2 is rational. So we conclude that root 2 is irrational. Clear, everyone? I mean, please go through the steps, practice, write and practice. Okay, you will get it. So for root 3 also just change the numbers and follow the same steps. For root 5 also change the numbers and follow the same steps. Okay. Now sometimes the proofs, right, show that will come with something like this. They will give something plus, like for example, they will give 5 plus root 2 or 7 minus root 2, something like that they will give. Okay. So in this particular case, no, the procedure is a bit different. So show that 5 minus root 3 is irrational. They will give this one. Okay. They will definitely give this one. Okay. In the NCERT it is not given, but they will definitely give a line, right? A line like that, given that root 3 is irrational, they will give a line for sure. Okay. So how do we start with this? Let us assume to the contrary that 5 minus root 3 is rational. So if it is rational, we can find, see what you can do now. The initial, this one you keep fixed. Okay. You write for all the answers, you write this one. So we can find integers A and B such that you can write like this. I mean, these numbers will change for sure. Sorry, here this will not come. Okay, but you keep that fixed. You see that we can find integers A and B such that 5 minus root 3 is A by B, where A and B are co-prime and B is not equal to 0. You keep that line as fixed. Okay, you learn one line. First, let us assume to the contrary that is rational. So we can find integers A and B such that whatever is given is equal to A by B, where A and B are co-prime and B is not equal to 0. You write that also. I mean, here I have written, I think so. See, look here. This one also you write. You have to add this. B is not equal to, you have to add. Okay. You have to definitely write this. Okay. So next, whenever we get plus, minus and all, no, we do some rearrangement. Okay. Here we don't do that squaring thing. We do rearrangement. Please remember, we do some rearrangement. Okay. How will we rearrange? We will rearrange in such a way that a root of whatever is given will be on the one side and everything else will be on the other side. So root 3 is on right side and everything else is on the left side. See, root 3 right side, this comes left side. We simplify. We do the rearrangement. We do the simplify part also. Now, if you see, left side we are having root 3, right side we are having this. Here, A and B are integers. Because rational number means A and B are integers. A and B are integers. So 5 minus A by B will be rational number. Because see, if you have integer by integer, it will be rational only for sure. Okay. Integer by integer is rational number. Obviously, this should not be 0. That is a condition. So 5 minus A is rational. If 5 minus A by B is rational, this should also be rational for sure. But this is already given that irrational. If 5 minus AB is rational, this should also be rational. But it is already given that this is irrational. But this contradicts the fact that root 3 is irrational. This contradiction has arisen because of our incorrect assumption that 5 minus root 3 is rational. So we conclude that it is irrational. Clear, everyone? Please, everyone, write and practice. Then it will come. Just remember that whenever plus minus comes, we do some rearrangement and then we write one side is rational. So this should be rational, but it is given that it is irrational. So it is contradicting and hence we say that it is irrational. Like that we say, okay? Same way we follow for this also, okay? It's already 9:30. So what do you do? I'll give some questions, okay? The questions I'll actually put in the WhatsApp, not WhatsApp community. I'll put in the Google Classroom. Okay. Or maybe I'll actually put. Okay, I'll put in the WhatsApp community itself the questions. Okay. You have to practice all those questions. Okay. I will create an assignment in the Google Classroom. You have to upload your answer sheet there. Next class, we are going to discuss those questions. Clear, everyone? Clear. Okay. Thank you so much, everyone. If anybody is having a doubt, you can wait and ask. If you don't have a doubt, you can leave. Thank you so much. Take care. Bye-bye and